Welcome back, and we're in part 2 of our study of the fundamental theorem. Remember, the fundamental theorem united the teams of people that were working on integration or finding the area under the curve by computing, infinite sums of small rectangles, and the people that were working on the tangent problem, or instantaneous rate of change. We saw that these processes were inverses of each other, or maybe should I say antis of each other, antiderivative. So we were talking about the antiderivative, and we came up for a general expression. If the function is equal to x to the n, the antiderivative is x to the n plus 1 over n plus 1. And you can quickly check that that works, and that's how my mind actually works. I always kind of quickly check about the derivative. So I think in terms of taking a derivative, and I say, oh yes, of course, if I take the derivative of this guy, I get back to that. Well, there's other antiderivatives we should talk about, and let's do that. What are other functions that we know? Well, let's see. How about we start with another function here. Favorite function, I love those trig functions. How about the sine of x? If we're integrating the sine of x, well, or finding the antiderivative, we got to think about what function, if we take the derivative of it, equals the sine. Let's see, I'm going to try to, maybe I could do it this way and be wrong first. I'll say, well, how about the cosine of x? I'm going to check that, and I'm going to say, well, what's the derivative of the cosine of x? Oh, that's equal to minus the sine of x. Is minus the sine of x equal to the sine of x? No, it's not. How can I take care of that? Well, I'm going to put a negative right here. Oh, that's nice. That came up red. I didn't even plan that, but I like that. It's good. Minus the sine of x, and then I would take the minus of a minus and make that a plus. So the antiderivative here is minus the sine of x. You need to know that. Okay, this is a list of ones you're going to need to know. What about, well, f of x equals the cosine of x? Well, let's try that. I'm going to say the antiderivative is the sine of x. If that's true, well, let's test it. What's the derivative of the sine of x? That's equal to the cosine of x. Yes, it is. Check, check. Okay, how about another one? Well, do I use the tangent? No, because I really don't know. Oops, no, this is just a... I guess I could say equal. It's fine. What if f of x was equal to the secant squared of x? It just happened to be the secant of squared of x. Well, what function, if I take the derivative of it, do I get the secant of squared of x? That would be the tangent, right? Equals the secant of x. We're interrupted by my son again here. Okay, the derivative then of that's going to be the secant squared of x. Oh, lost my pen. I guess I should have just put him on the air. Okay, just to keep this complete, what am I finding here? I'm finding a bunch of antiderivatives. If this is equal to x to the n, I'll write it down again. F of x equals x to the n plus 1, the power up rule. If I take the derivative of that, just like I showed you before, I'll get x to the n. And maybe I should write down here, these are antiderivatives you should know. Just like there's derivatives you should know. You should know how to take the derivative of the sine, cosine, and tangent, and the power rule. And that's pretty good right now. That goes. We do a lot with that. And also, you need to know the antiderivative of all these guys right here. Okay. All right. Let's work some problems now from the homework, and we'll call this second day done. Okay, here's a problem you'll see a lot, and you see it in homework and also on the AP test. They love these problems. Again, this is called the fundamental theorem. They like to make sure you really understand it. So here we have a function. Again, it's a crazy function defined by an integral, and we showed you how that works, right? In fact, if I would ask you what g of 6 was, you would tell me it's what? Well, if I put a 6 into here, 6 to 6, that's 0. Okay? Now, then I might ask you questions, well, find all the local maxes. Find the local max of g of x. Of g of x now. Local max. So local max. In fact, let's just say on g of x, I want the following. I want maxes, mins, inflection points. Oh, they're asking me all these things that require a derivative. Well, what's a derivative? G prime of x by the fundamental theorem is what, right? If I take the derivative of an integral, I get back to what I started with. So that's just f of x. So if I'm working this problem, I look up at this curve. What's f of x? It's just, instead of xt, I can put in x. There's no difference, okay? So I'm looking at it. So I go up here and I label this, and I'm going to label with a different color. When I'm working this problem, I say, oh, here's g prime of x. Now I'm looking at the derivative of the function. Hey, guess what? That's a local max. Okay, this here, let's assume this went underneath here. I'd call that a local min, goes from negative to positive. Okay, you used to know that that's an inflection point, right? These maxes and mins are inflection points, IPs. If I was going to talk about, remember all the properties of the derivative, this is concave up, right? Because the slope of the first derivative, this is concave down, this is concave up. Okay, so remember, we can ask you all kinds of properties of g of x by knowing what the derivative is, and that is the derivative, okay? That's the first type of problem. Understand that well. You'll see it again, trust me. Okay, well, let's try to go to this next problem here. A little bit of a harder one. Well, not really a harder one, but this is also h of x is equal to, and in this case, I'm going to give you 7 to x squared now, and I'm going to give you 6 plus dr. Now remember, this is r, 7r, right? I'm integrating on r. Well, I don't really know what h of x is. H of x has been defined as an integral, but they ask me, they want the derivative, or they want the derivative of h with respect to x. Well, what's that? What's that equal to? Notice what makes this thing a little bit squirrely is the fact that I got x squared up here, you see? Not just x. But let's start off and just say, well, I don't really know what the antiderivative of this is. In fact, it's impossible for me to find, but I'm going to notate it as whatever it is, it's big cap F at r. I'm going to evaluate that at x squared and 7. When I plug in the endpoints, well, what do I get? I get f of x squared minus f at 7. Okay? This is essentially, okay, this is equal to h of x is equal to that. Well, now I want to take the derivative of it, right? I want to take the derivative of this, and that would make me take the derivative of that. So that's what I'm doing. That's what I'm doing right down here. Well, let's break that down a little bit more again. That's the derivative of the antiderivative of x squared with respect to x minus the derivative of f of 7 with respect to x. This is just a constant, so the derivative of that is 0. Now, let's look a little deeper what's going on here. What's the derivative of the inside function? I got a chain rule here, right? The derivative of the inside function is 2x. What's the derivative of the outside function? Oh, well, we know the derivative of the antiderivative is just going to be back to the function we got, evaluated at the inside. Well, what's little f of x? Little f of x is that. And for whatever little f function is, we're going to plug in x squared into that function. Okay, so this is going to be 2x times the square root. That's the square root of 6 plus x squared is the input, right? Input to the third power. Okay, do you see that? 2x times the function f, which is just that, evaluated at x squared. So this would be equal to 2x times the square root of 6 plus x to the 6th power. Okay, and that would be the derivative of this function h. Okay, so notice we used the fundamental theorem, but then we had to remember the chain rule to get this correct. Okay, one more problem, just a straight integration here, and we're going to integrate minus 1 to 2 of x cubed minus 6x. It's hard for me to do an integration and not draw a picture. You don't need to draw a picture, but what the heck. Let's see if I can get a little picture of the function. It's always nice for me to look at a function. This is going to be, I'm going to pull out an x, and then I'm going to get an x squared minus 6. Looks like I'm going to get an x and an x minus square root of 6, x plus square root of 6. Okay, that tells me a little bit how to draw it. I've got a 0 here. I got a 0 at the negative square root of 6. Got a 0 at the square root of 6. I know it goes up to infinity like that. So this thing is basically going to look like this, okay? I'm trying to find the area, not the area, but the integral, which is going to be that might be minus 1, okay? And then I'm going to go up to 2. So if my picture is correct, I'm thinking this integral should be 0, should be less than 0, right? It looks like there's more area under the curve. Well, enough of the guesswork. Let's do it, okay? What's the antiderivative of x cubed? Well, that's just x to the 4th over 4, right? X to the 4th over 4. What's the antiderivative of minus 6x? That's going to be minus 6x squared over 2. Okay, so I might simplify that. Let's say that's x to the 4th over 4 minus 3x squared. I'm going to evaluate that from 2 to negative 1. Okay? Still doing my steps here. How do I check my antiderivative? If I take the derivative of x to the 4th over 4th, I better get that, and I do. If I take the derivative of minus 3x squared, I better get minus 6x, and I do. Now let's evaluate it. Okay, so I've evaluated at the top limit here. I put in 2 to the 4th over 4 minus 3 times 2 squared minus, okay, now I'm going to minus this whole second thing, minus 1 to the 4th over 4 minus 3 minus 1 squared. That's the answer. Got to do a little work to get a good number here. 2 to the 4th looks like it's 16 over 4 minus 12 here, okay? Minus, and be careful, a minus of a minus of a minus. So just keep this whole thing in brackets. I want to subtract off the whole thing. Minus 1 to the 4th is just 1/4. Minus 1 squared is minus 1, so minus 3. Oops. Okay. Let's extend this again. What is this going to be? I guess we'll put it over force, and we'll get minus 12. We're going to get 4 minus 12 minus. So this is minus 11 force, minus 12. So this is going to be minus 8 plus 11 force, or I guess that would be minus 32 plus 11 over 4 equal to minus 21 over force. And yes, my intuition and my picture seems to be correct. The answer should have been negative, and sure enough, it was. Okay, that's pretty good for part 2. We're ready to attack this, all the problems in this section about the fundamental theorem of calculus. See you soon.